Thanks to everyone for coming to this spaces. Today we're going to be talking, obviously hosted by the ZK team. We're going to be talking about ZK rollups or rollups on Bitcoin and how Citrea is leveraging this type of system to build a Bitcoin scaling solution. And we're also going to talk about how Zcash is going to be scaling and the different approaches there. So super excited to learn about the recent approaches in Zcash as well. My name's Janusz. I work on a research site called Bitcoin Layers. And yeah, I research a bunch of Bitcoin L2s and I used to work on Zcash. So I got a little bit of crossover going here personally. And think we can start this with just some intros. I think we can I'll kick it off to Nate, who can introduce himself and then we can go from there.
Yes. Hello, I'm Nate. I'm one of the Zcash developers. I've been around since the beginning, so it's been a good decade-ish. Um, yeah, and I'm excited to be here. I don't actually know a whole lot about rollups, and also in the Zcash world, I'm not really the ZK expert, but I can sort of do my best to tie the big picture stuff together.
Cool. Awesome. Thanks, Nate. Talip, you want to go ahead?
Yeah, sure. Hi everyone. My name is Talip. I'm a DevRel engineer at Citrea. Before that, I was a protocol engineer, kind of working on the client side rather than the bridge side that all the crazy Schengen is going on. Um, yeah, I'm also not a crazy ZK engineer, but like I kind of know the concepts and I know one thing or two about Bitcoin rollups. So super excited to talk about it.
Cool. And do we have anyone with us from the Shielded Labs account? Just want to make sure I'm not missing anybody on the intro side.
Hi,
Hey guys,
sure. Oh yeah.
it's me, Jason. I'm with Shielded Labs. Yeah, just listening in on this one, but happy to be attending.
Okay. Cool. Awesome. So there's a couple of ways I want to take this conversation. We do have a little bit of time. I've got like an hour slotted, so I feel like we can take our time to work through all these things. They're pretty complex, and I feel like Nate, you, myself, and Talib, we can all just like ask each other questions. They can keep this pretty free flowing. The first thing I want to talk about though is just setting context. Let's just talk about it at a really high level, like how blockchains, I guess, like agree on a current and new state. So Nate, if you want to talk about this from like the Zcash side, how does Zcash essentially update its state at like a very high level? Like how does Zcash work when a bunch of new transactions are included in the chain? How does like that state transition function happen?
Sure. Okay, so Zcash's blockchain, its original design was it's a fork of the Bitcoin core code from a while ago, and with a lot of changes since then. Um, so the design of the protocol is one where wallets submit transactions that get sort of spread around the network of nodes, and then miners collect those transactions, bundle them into a block, and then try to find a solution for the block. So it's very similar to Bitcoin in that regard, although we're planning on changing this consensus layer in a while, like maybe 18 months. Um, so the state transition function is again kind of like Bitcoin with this extension. Where our transactions can have zero knowledge proofs in them, and that provides shielded storage and transfer of funds. Um, and in addition to like verifying all of the what we call transparent transaction rules that are very much Bitcoin like, we also look in the transactions for the zero knowledge proofs and verify that those proofs are valid. Um, and there are a few like consensus data structures that nodes need to track in memory that are distinct from Bitcoin, but I'm not sure what I think that's probably like a good level of detail for now, unless anyone has questions.
No, totally cool. I think that's a good way to kick this off. And then I'm just gonna go again very high level, kind of hand waving here. Bitcoin works in a similar regard. Not exactly the same, but like I guess at a very high level, you could say that Bitcoin works in a similar regard. So Talip, what does within this style of like, having an old state, a current state, and a new state, how do rollups work? Like what is a rollup? What type of like is it a blockchain? Is it a layer 2 solution that isn't a blockchain? Like at a very high level, like what is a rollup? And then we can kind of get into like how rollups work. Just want to at a very high level, what's a rollup?
Yeah, sure. So I think the best way to talk about this is comparing to what is not a rollup initially in a sentence, and then we can go over it. So rollups are blockchains, and just like pretty much almost every blockchain that I know of, they have a function that does state transitions, which means from one point to another, there are some transactions happening and there are some rules of the network. And then based on applying these rules, you get a new state that is accepted among users. Well, the thing is, what makes a rollup different from another blockchain is, so if you are running a blockchain, or if you're basically producing blocks, then that means you preserve the state of this blockchain on your own local computer or on your own machines. So rollups differ on that end because they post their data into another blockchain. So you may ask, why you do this? Why does this matter? And in fact, this kind of matters because, so if you publish your data into another blockchain and use it as a data availability layer, then that means as long as that blockchain is functional and as long as that blockchain is not bugged and always open to public in a way that, there are some security guarantees on its own, functions nicely, then that means your data is sound and secure on that end, and you can always use this. So this is kind of the definition of rollup that I have, which actually kind of different than what many Ethereum people possess on their ideas, but this is enough for a rollup to be alive. It is a state function, it's state transition function that reads this alternative layer and always confirms that, the transactions happen and data is sound and secure over there. So for Citrea, it's a rollup on Bitcoin. That means we publish our data into Bitcoin and use Bitcoin as a DA layer. Who does this is a good question, and the answer is there's a sequencer and there's a prover that we have. So sequencer orders transactions and basically determines blocks, and then prover on its own generates ZK proofs or validity proofs alternatively in a more better way for these execution to be verified by end users. And you as the end user can always run a full node, and using this full node you can always receive the transactions from sequencer, and then you can always check Bitcoin for everything going correctly or not, and in case it doesn't go right, then you can always throw out error, and then everyone will know about it. But again, like, maybe if I dive too much, but in summary, a rollup is a blockchain that publishes data into another blockchain for its security.
Okay, cool. And I do want to touch on that and like dive into that a little bit, but I'm going to pause. I'm not going to, and I'm going to ask kind of another high level question just for context setting. Both projects, Zcash and Citrea, are using snarks, ZK snarks, zero knowledge proofs, validity proofs, whatever you want to call them. But they're using them for different ways, right? So my kind of understanding is that the snarks that Zcash is using are more for privacy guarantees, whereas the snarks in Citrea are more for this proving of the validity of execution and some added scaling benefits. So I want to ask both participants. Nate, we can start with you. How does Zcash leverage zero knowledge proofs right now? Is it more for like the privacy or the scalability side, or is it a combination of both?
It's for privacy almost completely right now. Yeah, there's a little bit of like scalability style stuff within transactions, but that, yeah, it doesn't have like a major impact at this point, except for very large transactions.
Okay, cool. And then Talib, on your side, Citrea is using these proofs just to like attest to like some attest that the execution was handled correctly on the L2 side.
Yeah, so we don't possess the privacy aspect of ZK proofs, which is in contrast to Zcash, where they do nicely, which I like. But rather we use the Snark proofs for succinctness. It means, let's say there's a bunch of transactions, let's say thousands of transactions. And what we do is essentially we compress this in different ways, and we generate a Snark proof where any full node can basically just check this proof along with the data to see, like, there's no need for re-executing everything. You can just check the proof for scaling in a better way. That's not the only way we use it. We also use it for the bridge component, but that's another discussion, I would say. But yeah, the core idea is we're using it for the validity purposes, and we only use the succinctness property of a ZK proof, whereas on Zcash it's more for the privacy focus.
Cool. So I think we've done some decent like context setting to start this conversation. So I want to dive really quickly into just rollups. Like I think for like the next maybe 15 minutes, because for people who actually don't know, I wrote a proposal in Zcash to actually that the idea was to make Zcash a rollup using either Bitcoin or some other blockchain for data availability. It was not received very well. I don't think people wanted to do that, but I think we can kind of focus in on, because I think this conversation is kind of focusing around on how maybe Zcash could one day do rollups itself, and maybe Zcash is a data availability layer. Or there's like kind of this like modularization component of these different systems. So I feel like for the next 15 minutes, let's just really dive into this roll up idea, kind of expose kind of the Zek Hub audience to this. And then yeah, we can kind of go into how these different things, how these systems might differ, and how Zcash's kind of new consensus layer and new scaling proposal might be different from rollup. So Talip, when you talked about a rollup, you said it's another blockchain that, like any blockchain, applies some state transition function over some data to create a new state. But you mentioned this thing called data availability. So you said it posts its data to a data availability layer, and that's how like the nodes are able to kind of check the state, query the state, and also generate the state when they spin up their own nodes, or recreate the state based on this data availability layer. What does data availability mean? Does it mean that the nodes are responsible for storing the data long term? Are they able to discard it? What does data availability mean in the context of rollups?
Yeah, sure. So I think one very good way of answering this question is, so this is called data availability, and I guess the question is, do you need the data to be available of a blockchain? If yes, why do you need it? So I think this is kind of the notion itself seems like self-explanatory, but the idea is, so a data availability layer says I will always have enough information about every transaction that happened on a blockchain so that you can always query me as the source of truth for this data, and then you will always be available to, verify it. So this is crucial because for blockchains, let's say you don't have any access to the state of a blockchain. Okay, let's say you had some money, and then something else is going on that you have no idea about, and then let's say you wanted to even utilize it at some point. But the truth is, if you don't have access to that, if you don't have access to the state overall, in terms of these traditional blockchain architectures, I mean, if you cannot access your own state, then it can be a problem because you may not know how to utilize it. You may not be able to use the RPCs with the correct data. You may not be able to independently validate the state transitions or recover the correct state. So let's say there has been a fraudulent update that you weren't aware of, then in that case, if you don't have access to the data, then you cannot really challenge it or raise your voice about it. So kind of we use data availability specifically for rollups because in case someone as a rollup entity, either an operator or someone else, tries to act in a malicious way, then with the DA layers, you can make sure that you can at least initiate the actions to punish them or initiate the actions to make sure that they cannot do it. So in practice, all the data availability stuff is about making data always accessible and public so that it cannot be withheld by someone. And in different layers, it's kind of handled in different ways. In Bitcoin, we publish these into UTXOs using using SegWit transactions, using the witness data, sorry. And on Ethereum, there's additional stuff like blobs that they use. And if you go to Celestia, for example, they have a different idea called data availability sampling, where it makes it much less costly for operating a node that stores all this data. But the core idea is, again, if you don't have the data, then you add some trust assumptions, and basically the DA layers get this trust assumptions. And if you use Ethereum, then as long as Ethereum is secure, then data is always there in an unbroken way that you can always access. On Bitcoin, it's the same. On Celestia, it's a good DA layer, but it's there. Your blockchain data is secure as long as Celestia is secure and unmugged. So this kind of stuff seems like doesn't matter, but I think they will matter when they matter, and it'll be important, if it makes sense.
And kind of the idea based on Bitcoin is as long as there's one kind of live full node that you can connect to from the Bitcoin perspective, you can then run a Citrea full node, recreate the entire history of Citrea based on that data, and then do whatever you need to. Like maybe you want to submit your own exit transaction, maybe you want to challenge an invalid state transition, or maybe you want to just kind of have access to that state. Based on that, that's like the security assumption. And that changes from chain to chain. But from your guys' perspective, Bitcoin is kind of this Wagyu, like high end, the most secure data availability layer out of all the options, because there probably are more efficient kind of chains like Celestia or Ethereum, for example.
Yeah, definitely. And it's also, kind of combining everything together, like the idea of, Bitcoin being not fully utilized, let's say, which is a debatable topic, but anyways. And then the idea of building a secure enough bridge that can cooperate with Bitcoin sidechains, and then making this Bitcoin sidechain directly on Bitcoin so that you get a rollup sidechain, which some people call. And I think it's like it was a match in heaven when we started to work on it and everything came together. But the core idea is we want the system to be recoverable and secure enough as long as Bitcoin is secure enough, and which we believe it is. This is kind of the core idea that we have.
Okay, cool. Nate, did you have anything that you wanted to follow up on there? I want to check before I move to the next question.
Yeah, I mean, there's a lot I can learn. So the first is, it sounds like users of the Citrea rollup can interact with base layer Bitcoin, right? Like can they send and receive into the rollup?
Yeah, so it's kind of called the forced inclusion stuff. So on Ethereum, this is possible. What you can do is you can, in case sequencer is trying to censor you or stuff like that, which happened actually. I think I'm not going to name names, but in one of the blockchains, the sequencer was kind of from the RPC was blocking people to mint some ERC20 tokens with some racist names. And what these people did was basically just calling a smart contract on the Ethereum L1. And by using this, they were able to update the state of the Ethereum rollup. For Bitcoin, there are mechanisms that we are trying to come up with. This is something called, I call it as forced inclusion, where in case a sequencer is trying to censor you or stop you, you put your data into a form onto Bitcoin L1 as a user, and then the circuits and everything basically designed in a way that the state transition must happen by including that transaction. Otherwise, like in the concept of finality, it won't be finalized. So the team is kind of working on it, but right now we don't have that. And on the mainnet launch, we may not have that. Like if we have it, we will probably say it. But the ideas are called like forced inclusion and also the self-proposing state transition stuff. But they're not on practice for us at the moment. We're working on it.
Cool. Oh, yeah, some other just general context. When are you aiming for a mainnet launch?
Good question. In a couple months, maybe, or sooner. We will see. But I don't personally, I don't think it will be I think it will be around a couple months, to be honest. But I don't think it will be next year, let's say.
Right. The other basic question is, So it's possible to have your own state transition function, right? Like your own rules. So does Citrea offer like different semantics than Bitcoin?
So as a user, you cannot change the state transition function. So it's like, there's this, well, you can change, but then that means you forked off. So, and for the Citrea itself, there's only one state transition function, and you'll is, kind of obliged by it.
Yeah, but Talib, really quick, I think also though the logic that like Citrea is executing is very much different than that of Bitcoin, right? It's executing like an EVM execution environment where you're offering like more expressive smart contracts and different scripting languages and things like that as well. So
Yeah.
while like the users have to execute that state transition, it is different from Bitcoin in the fact that you are offering some arbitrary execution environment.
Yeah. It's like all the data that they propose must fit into the EVM EVM specs that Citrea already possess, and it will be like it will be in the same canonical chain that Citrea goes on to, if I understand the question correctly.
Yeah,
Yeah.
yeah. That's so in Zcash land. So Ian, by the way, when you propose roll up stuff, I don't know what the reception you got was, but I love hearing different ideas for how Zcash could evolve. Um, and I'm also getting interested in rollups on Zcash primarily because um, we want to or like I want to see more functionality go up. But it would be really nice if there were sort of a separation of layers. So if there could be a base layer that was simpler, and so there could be higher confidence that it is more secure, and then maybe we could use something like rollups to have like new transaction semantics, like an EVM would be a great example.
Yeah, like I think that's like I think for me, the original thought I had was that, when I thought about it, because this is the thing we talked about. I went to I think it was a while ago, one of the ECC conferences, and I can't say who said what because of the it was under Chatham House rules, but I can say that like when I did give a presentation on Zcash using an alternative data availability layer. But there is a couple problems with that, right? So like let's say you use for example, just some proof of stake blockchain that has like its own validator set, and that's like the blockchain that you're posting all of this data to. The problem in the context of something like Zcash is obviously like Zcash is fully encrypted private transactions, which come with like certain like maybe some validators wouldn't want to include those types of transactions because they're fully private and they just don't feel comfortable including that in their own chain. You could get a situation where a percentage of the validator set could start censoring um like blobs of data that come from Zcash, like the Zcash rollup. So that was like one of the issues that kind of came up when I was proposing this, is that you entrust another validator set to make this data available so your blockchain can continue to like work. What the cool thing with Nate right here, like I think that is actually a good idea, that you could have Zcash as like kind of this base layer that is consistently making the data available not only for Zcash transactions, but for transaction blobs that are like for different execution environments. So to do fancy things like EVM style smart contracts, Cairo smart contracts, whatever kind of execution environment you want. So those are kind of like the two different approaches that you could go with Zcash, and I think people kind of prefer the latter of it. So Talib, but though I think another thing Nate was asking is something I wanted to get into next, because with either doing that for a Zcash style blockchain where you want like an EVM smart contract environment, or like with Citrea with its own EVM smart contract environment, we need to get like on Zcash it would be ZEC the token, but in Bitcoin it's BTC Bitcoin the token. How do we get the token onto the blockchain? So like I don't want to just do a bunch of self-included forced included transactions, because within that I'm just paying Bitcoin L1 transaction fees. I have to wait for Bitcoin block times. That's like very, very slow. So if I wanted to leverage the roll up in kind of a more scalability sense, how do I get the actual like main chain asset from the data availability layer onto the roll up? Like how, like, so people call this a bridge, but I'm interested in kind of hearing kind of like what your high level description of this is.
Yeah. So I guess the question is reframing it as, so let's say one day we managed to make just a thought, we managed to make a Zcash system where, that publishes data into Zcash, and then it's essentially a Zcash layer 2 with much more stuff that you can do. But then the problem is how much you should trust into that system, because this is going to be a real environment, and in this real environment you will have your money, you will have your own funds, and to what degree of functionality, how much of security of Zcash or Bitcoin are you willing to sacrifice? This is a great question, because the money in blockchains do not appear from air generally. Well, actually, people do airdrops, but which is, I don't like it too much. But on the other hand, if you're as a real user wants to move his funds into an alternative blockchain, then you need to use a system which people call bridges, essentially. Um, Bridges are basically systems where you deposit your funds and be able to also withdraw it back between two blockchains. But the problem is there are different type of blockchains with different type of VM environments where you cannot do everything you want. What I mean. So let's say you want to move your funds from one blockchain into another in Optimism ecosystem, or let's say two ZK environments, okay? And what you can do is you can use knowledge proofs to just, and then you can have two different light clients on two different blockchains where one verifies another, and then you can basically get wrapped version of assets in other blockchains without need to touch to anyone. But then for Bitcoin and for a bunch of blockchains as well, this is kind of a problem because you don't have this expressibility, and you also kind of need some social consensus for stuff to be accepted as well. So for Bitcoin today, what we have is, if you want to go into Bitcoin side chains with your funds from Bitcoin L1, you basically give your money into someone, and then these people with validators or signers basically held custody of your funds, and then they basically give you an equivalent amount of money in this alternative layer, and then you can do whatever you want with that. And when you want to come back, you also go back to these same people if you want, like if you want to do it between these two blockchains, obviously. And then you also want them to give your money back. So this is kind of what we have today. It's mostly achieved by multisigs or NPCs, or like alternative cryptographic systems that depends on honest majorities. So it's like you give your money into 5 people, that 3 people can give you the new money or move the money in any way they want. And this is kind of a problem, because let's say if Bitcoin price goes into $1 million or $10 million in a hypothetical scenario, then 3 people can get too ambitious. You will never know, because there are no problems today doesn't mean that there won't be any problems tomorrow. So again, like, making chains are cool, and it's actually super cool idea, but moving funds around is a problem. So yeah, I guess like this was kind of the general answer, but do you want me to go over into what we have, or like do you want to stop here?
Yeah, so I mean, I can provide a little more color because
Yeah.
I would say most of my research right now is on kind of Bitcoin bridges. And I think Zcash might be able to, and I'll ask a follow-up to you, Nate, because I think Zcash might be able to escape some of these problems because it has a little bit more of an advanced scripting language. But I think with Bitcoin, right, like what Talip said, like the biggest kind of signer set that we've seen for a bridge in practice, so a bridge meaning moving Bitcoin from Bitcoin to another blockchain, whether that's a rollup, a sidechain, Ethereum, or whatever, is 35 signers, and this is the TBTC bridge on Ethereum. But what people also don't understand is that this is like a permissioned kind of set of signers where a kind of DAO, a governance mechanism, has to vote the signer into the signer set. So you can't just go buy T tokens, stake it, and then become a signer in the set. We've actually never in practice seen a permissionless kind of distributed Bitcoin bridge. Everything is federated in some sense. The closest thing we have is there's a Cosmos chain that has its validators like participate in a multi-sig. So the top 20 validators by their stake get to like have a signing key in this multi-sig. But the token isn't currently transferable on an open market. So none of the validators like are able to sell their tokens or transfer their tokens. So it's not in practice. It's still a federation because no one can just go buy, a bunch of tokens and become a signer in the bridge. So we've never actually seen this happen in practice. So I think it's really helpful context to understand another motivation for building a Bitcoin rollup is that rollups, because of some fancy stuff, can actually build better, or not, maybe not better, but bridges that have different trust assumptions rather than trusting an honest majority group of people, trusting that the majority of them won't collude and steal the funds. Rollups can actually do a different style of bridge that has a minority trust assumption. And Talip, you can dive into the fancy stuff that you guys are working on right now. But I think that at high level, there's a reason why people are building rollups, and another reason, there's two. One is the recoverability of data, and then the second thing is building these better bridges. So, Talip, if you want to give a really high level overview of how you guys are planning on bridging Bitcoin into Citrea, that'd be super helpful.
Yeah, I think before that, I just want to Nate, do you have any thoughts or questions about these or any notion that we skipped?
Not really. But I see some tie-ins mentally to Zcash, like how we might grapple with some of the challenges. But yeah, let's dig in first about
Yeah.
bridging. Yeah.
Yeah, for sure. So yeah, I guess so let's say we made this from the beginning of the conversation, I mean. So we made this cool chain. We believe that it's super cool. It will scale everyone and it will be super helpful, and you will be able to utilize whatever assets that you want to facilitate, in which case it is Bitcoin for us. But the problem is, how much should I trust you and how will I move my funds back and forth? So today, again, most of the solutions are honest majority. They work, to be honest. So far, most of them worked very nicely, but you will never know. And again, these are kind of honest majority assumptions, which are kind of risky still. So one popular idea that came around is an idea called BitVM. So again, BitVM is, just to clarification, BitVM is an algorithm, is a mechanism idea that is used to verify ZK proofs in a way. And using this technique of BitVM, we can do bridges. So that's why I prefer to call them as BitVM-based bridges. So BitVM is not a token. It's not a VM, actually. It's not an execution environment, which many people confuse with. Or it's not a name of a bridge. So BitVM is an idea of doing ZK verification. And the core idea is, so we can do optimistic fraud proofs on ZK. The core idea is, in case, so there's the core idea of BitVM bridges goes like this. If everything goes right, you don't really do any ZK verification kind of stuff. But in case something goes wrong, there is a mechanism that you can kind of question the integrity of a ZK proof that should be provided by necessary entities or like the responsible entities. What I mean by that is, let's say there are 10 people who holds the custody of funds, and in case someone gets suspicious about an action of these 10 people, they can challenge these 10 people to provide a correct ZK proof, a correct light client proof. And in case they fail to respond, or in case they respond in an incorrect way from the perspective of Bitcoin, then they get slashed and they get kicked out of holding these funds. This is super important because, you now get a mechanism in which you can challenge people to do everything correctly, and in case they don't, you can kick them out. So compared to what we have today, where people can, in an honest majority way, do whatever they want, this is super huge. And you use basically ZK proofs for this, relative proofs for this. The BitVM idea came around late 2023, and then the implementation and then there was improvements, like there was the BitVM based bridge idea 1, and then there's this BitVM 2 based bridge idea, which is much more practical and much more functional. And then there's even the idea of BitVM 3, which uses some other crazy ideas to do this. But the core idea is you get a system, you get a bridge design where you can kick out or slash people who holds the custody of your funds in case they do something malicious. So then are they trustless? The question is then, like, when you be, how does the deposit and withdraw schemes work? I guess like I think I can give a pause here and then maybe go into that later a bit in case this was too long. How do you think?
Yeah, I think that the kind of the key thing is that you don't have a property with this type of bridge where you can just like unilaterally take your money. Because like the idea is like bridging in is like fine, someone just needs to like take the money and then give you the representative like token, the Bitcoin token on Citrea. Kind of the bigger, I guess, concern would be, or maybe it's not, but to me, would be to get the money out. So like let's say that you want to leave and you want to move back to Bitcoin. There's no way to like unilaterally go to the bridge and say, give me my money back by supplying some proof of information. But what you can do, so there is that trust assumption and the fact that someone has to give you the money back. But what you can do is you can stop anyone from stealing, which you can't do today. Today, any of these bridges, any of these wrapped Bitcoin tokens that you see on different blockchains, there is somebody or some group of people that can steal all the money at any moment, and there's no way to stop them. Whereas in like a BitVM style setup, we have found potentially a way to build a bridge where you can stop people from stealing the money. And you just need one person to be honest in the entire system to have that person stop from stealing the money. Yeah, and the reason, and I guess this might be a good follow-up question to Nate really quick. The reason that you can't build like how Ethereum's trying to build it, where you have like a ZK bridge where no one, there's no operators, it's just a smart contract, is because Bitcoin scripting language is really limited and it's not expressive enough to build these types of smart contracts that are able to basically like be convinced of an argument from the rollup, and then they can't update it. They can't update their state accordingly, because the size of that would be too large to fit in a Bitcoin block. Because Bitcoin blocks are really, really small. I think they're like 4 megabytes is like the maximum block size. So Nate, I guess the question I have for you is like, do you think is the scripting language in Zcash expressive of enough to build kind of like a construction where you could build like a bridge that just automatically updates its state based on some ZK snark? I'm just kind of curious if that's even possible because I'm not really familiar with Zcash scripting language.
Yeah, well, I think it's possible, but not through the scripting language. So, one thing about Zcash is we've embraced hard forks since the beginning. So that one thing about that is we can make backwards incompatible changes. Um, and so as we've added new functionality, the way we've generally done that is we add new transaction fields that are different from the transparent fields that use Bitcoin script. So then when there's a particular feature, we just sort of implement it kind of in the native way in the full node instead of relying on Bitcoin script. So it's sort of like there are it's hard-coded functionality for like specific features. So yeah, I think the way it would look in Zcash is we would figure out what are the requirements for interacting with a rollup or a bridge, and can we sort of program that up as like a new transaction field.
Okay, cool. Totally makes sense. So I think now I do want to pivot kind of over now to the Zcash side of things and kind of maybe explore, and maybe Talip, you asked some questions as well to Nate, kind of explore how we might be able to do this, how rollups on Zcash might work, and kind of look at the current Zcash roadmap from scaling and kind of compare and contrast the two different solutions, or many solutions, right? Various solutions. But I do want to kind of close on the Bitcoin side with a summary. And can you fact check me on the summary, Tal, if that's okay?
Yeah, for sure.
Cool. So the roll up is essentially Bitcoin's a blockchain, and as a part of that blockchain, and the transactions that it does, it's able to store basically arbitrary data. So data that to Bitcoin doesn't really mean anything, but to some other system, it might mean something. And a rollup takes advantage of that by taking its entire state, and compressing it and making it fit within a Bitcoin block, but taking its entire state and sending it to Bitcoin in the form of a transaction that contains this arbitrary data. And then the rollup full nodes are able to derive the state and basically apply the state transition function over this data permissionlessly, as long as one Bitcoin full node or some group of Bitcoin full nodes are online to make the data available to them. So you can basically create the state of the blockchain by only relying on data that's made available by Bitcoin, not another full node set. And then that allows you to build a blockchain that has security guarantees of Bitcoin, but allows you to do like a bunch of crazy other execution stuff. So like EVM, Cairo, different types of smart contracts, whatever, that are more expressive than Bitcoin. And to get money onto the rollup, we need to build a bridge. And the cool thing about having the data made available by Bitcoin is that users can like kind of reconstruct the state, and they can understand what the actual current state is. And they can also check that against what the bridge operators say is the current state. And if the bridge operators lie and try to cheat, then anybody can challenge them, because they also have a record of this state and are able to basically say, hey, you're lying, I'm going to challenge you, and that operator gets slashed because they're trying to steal the money. So that's kind of like at a very high level, you're building a system that, one, has the ability to recover its data and reconstruct the state based on Bitcoin full nodes security guarantees. And two, you're able to basically create a bridge where anybody who has access to this data can challenge a malicious operator who's trying to steal the money, instead of a system that where any majority of people can just steal. Is that like very high level, hand wavy, pretty much a good way to describe it?
Yeah, true. And one last
Okay.
comment is, we do all these Schengenians because there's no way to natively prove a ZK proof on Bitcoin. If that was possible, then you probably wouldn't need anyone to hold custody of your funds, and you could just prove how much money you had and an exit. But because we don't have it, we need to play all these ZK games in cryptography.
Yeah. And really quick to add as well, there was actually there's an opcode that was disabled in Bitcoin a very long time ago. Some people are arguing that you should bring it back, and it's very simple. In essence, I think it's only adding like a few lines of code back into script. But yeah, someone actually built an entire ZK verifier, which is this one opcode, very expensive, not very efficient. But someone actually did that. So to actually build like this native ZK verifier in Bitcoin, at least, you only need potentially one additional opcode.
What's the name of that one?
The opcode's called, I can actually text it to you. So the opcode's called opcat.
Okay.
And then there's a code base called Bitcoin Wildlife, where they're doing a bunch of stuff with cat, and one of the repos is a native ZK proof verification with script.
Cool.
Yeah, I can send that to you. But yeah, so I want to go over to the Zcash side, because we only have 16 minutes left. So we've talked a lot about rollups.
Yeah.
Again, rollups are they're really easy, but then when you start getting into the bridge at first, then you get into all the details and complexities, then they get kind of hard. That's like the story of rollups. But Nate, you mentioned that you're kind of interested in Zcash potentially applying this type of thing. First thing I want to know, though, is in the beginning of the conversation, you talked about a consensus change to Zcash. So I want to cover that. And then the second thing I want to ask about is, how is Zcash kind of thinking about scaling and kind of increasing throughput so it can do more transactions per second? I want to talk about that before we kind of maybe wrap up with comparing the two different solutions. But yeah, I kind of want to learn a little bit more about how you guys are, because right now, currently, I think proof of work, kind of very kind of similar, I would guess, into Bitcoin, and kind of how we mentioned earlier how the state transition function works. But yeah, kind of interested in how you guys are looking at your new consensus layer.
Okay. Let me tweak the topics though, because the first thing is you asked about the consensus change that's coming up. That one isn't like directly relevant to scaling or rollups or anything yet. So that one is just transitioning to a hybrid of proof of work and proof of stake. But it doesn't change, like transactions will still go through proof of work blocks. And it doesn't change the scalability of those directly. So I sort of feel like we could put a pin in that one, maybe.
Yeah, let's put a pin in that. Yeah, let's do that.
Yeah. The yeah, and then the other two topics is that there is like a roadmap for scalability, high throughput transactions. And then there's my personal interest in rollups is a little bit distinct from that. It's more about functionality. Like, so for that, what I'm interested in is, can we make it possible for anyone to show up and permissionlessly sort of add new rollups or zones or something that can have new functionality that users can opt into, but they don't have to, because I would like to see more like experimentation and stuff. So yeah, so there's that. And then there's our scalability roadmap, which is called Tachyon. So with, which should we dig into next?
Okay, let's do the because the roll up thing is really interesting, but I do want we go there now, we won't talk about Tachyon. So I want to really quickly talk about Tachyon before we go back to the roll up side.
Yeah, and the roll up side, there's nothing like too unique about Zcash, so that would just look similar to adding roll ups to other chains. So it's something I want to learn about, but maybe not, not you guys. Yeah, so the Tachyon is this code name that Sean Bowe, who's like one of the Zcash wizards, has come up with. And so it is like a new architecture for the blockchain that has really good scaling properties. It is specialized to Zcash-like shielded transactions. And so those are really limited at the moment. They're just transfers. It's possible, I think, to extend this kind of architecture to have some kinds of programmability, more akin to maybe Bitcoin script or something like that, by changing which zero knowledge proofs are used in the transactions. But that's not like a main piece of the architecture. So I'm just saying that so that anyone who wants to scale other stuff like a smart contract system knows that this architecture might not work very well because it's specialized. So it doesn't actually change the consensus layer itself, and so it's kind of a orthogonal to the consensus system. So it could work on a proof of stake system or a proof of work system or whatever. It's a little bit agnostic to that. Except it may, I might be glossing over. I think it may depend in some ways on having like assured finality. So basically a guarantee that certain blocks won't roll back after they're a certain age. And so you can do that with a proof of work system if you just pick a given block height that you are, and then the whole architecture might depend on there never being a rollback greater than that size. Okay, so it doesn't, Tachyon doesn't change the consensus system itself, but it does change the transaction semantics. And it's a little bit technical, but I mean, it's very technical, very technical, and I'm still learning bits and pieces. But what Sean realized is, with our existing shielded transfer protocols and Zcash, there is, let's see, how do I put this? There's a something called a nullifier, and it is, in Bitcoin, when you spend a UTXO, it can't be spent again, right? Because that would be double spending. So you don't allow that. In Zcash, with shielded stuff, the nodes don't see what are the UTXOs that, in the shielded pool. So they're sort of like encrypted. But instead, there's this value called a nullifier that's associated with each one. And when it gets spent, that nullifier is publicly broadcast with it. It's part of the transaction. So it's sort of like a flag saying, I, there is a UTXO. It is now being spent. I can attest to that. And so to prevent double spends, the validators or full nodes just look for duplicate nullifiers. Any duplicate nullifier would be a double spend. So That's a little bit about how double spend protection connects to the shielded encrypted stuff. In all of the current protocols, you know, it's important for the nullifier to be derived from the UTXO, or we actually call them shielded notes so that we don't confuse them with the transparent UTXOs. It's important that it's derived directly from that, because you don't want like an attacker to generate different valid nullifiers for the same UTXO, because then they could do double spins. So that's important. And then the other important piece is that it can't be revealed early. Like it is associated with spending the note. So if any sort of privacy attacker can discover it early before the spend, then they can notice later when a note is spent. So that's kind of subtle, but it's important for the super strong privacy properties Zcash has. And that's in like the current protocol. So the insight that Tachyon's built around is, I'm not gonna be able to say it precisely, but it's basically realizing that there's a way that those values, those nullifier values, can rotate over time for a given shielded note without allowing double spins. So in any given like time window, or it's actually like a block height window, and note still only has a single valid nullifier, but that value can change over time. And the implication is it basically allows the full nodes to be able to forget older nullifiers. And in current Zcash, they have to remember every nullifier ever seen. So in Bitcoin, every full node has to remember every current UTXO. But then once a UTXO is spent, they can forget about it in their working memory in like, the blockchain state. In current Zcash, we have like this worse problem where we have to remember every spent note. So that grows unboundedly. So it's like a scaling problem. And also it's a little bit of a scaling problem because in order to check a new nullifier isn't a duplicate, the list you have to check it against, or the set, is getting larger and larger. I don't think that matters too much for performance, but it is it doesn't matter as much as just the fact that the set keeps growing and growing. So basically the implication of Tachyon is it requires changing the way transfers work a little bit, and there's still a lot of like design details that are open, but so once that is done, then it's possible for the okay, here's another can of worms. To support light wallets or mobile wallets in Zcash, there's a service provider, like a backend service. And the wallets can, switch between those or like choose different ones, but there is like privacy degradation for using those. So basically a Zcash full node wallet still has much stronger privacy than a mobile wallet. A mobile wallet still has privacy, like the transactions are encrypted and stuff, but a service provider, a backend service provider for the mobile wallet, can sort of like correlate when they see encrypted transactions, leaving and arriving at different IP addresses, and sort of infer linkages that way. So it's kind of working around the on-chain encryption. With Tachyon, that privacy piece gets improved, like I think basically completely, where the service provider is like indexing stuff on the blockchain on behalf of wallets, but can't learn anything about when the wallet is receiving or sending a transaction. So there's still that sort of infrastructure component, but its privacy improves, and then also um, the full nodes no longer need to memorize every nullifier. And then there's a third piece, which is like an aggregation thing, which is using zero knowledge proofs for the concise part, which is where you can take a bunch of transactions and sort of squeeze out everything except these nullifier values, so that the the size they take up on a block is extremely small. So the architecture has many pieces. It'll take a while to get there, and different components will roll out over time. But once it's there, it'll have some really nice properties. So one is mobile light wallets will still have really good privacy, like basically as good as full node wallets. Um, there's this other detail where they won't have to scan. So currently, they need to connect to a service provider, and then to try to protect their privacy, they kind of have to scan new transactions that they haven't seen since the last time they were connected. And so that means in practice, if you have a shielded mobile wallet, when you open it up or when you turn it on, you have to wait a while for it to sort of catch up to the blockchain. And if it's been a while since you've opened it, that can get really cumbersome. Like it can take hours, to sync out. That problem goes away. And then, yeah, the final piece is with the more compact blocks, the throughput can be a lot higher than what we have on Zcash today. So that's an overview.
Cool. Awesome. Thank you. It actually, I'm hand waving here again, but it sounds actually similar to a construction that some researchers are working on in Bitcoin. Where you basically can like aggregated, like, so the only like data that you would need to post to Bitcoin in this sense would actually be the nullifier, which is kind of a scalability benefit for Bitcoin. But you can do like an aggregation technique as well, where like an off-chain service provider can like aggregate a bunch of these things and kind of post one aggregated kind of nullifier
Right.
to Bitcoin. Yeah, so that's like a thing people are working on as well. But I think like kind of like on a finishing point here, that sounds though like you mentioned in the beginning of that is like that is specifically maybe you could do some programmability, maybe you could do some added functionality with some like pretty like kind of like high level arbitrary smart contracts, but like it mainly is focusing on kind of scaling throughput and the amount of transactions that Zcash can do, and also minimizing the amount of like storage data needed to run a full node.
Yeah.
Yeah.
Oh, I missed one other piece. I mean, I kind of mentioned it, but because full nodes can forget old nullifiers, their storage requirements are relatively small and kind of fixed, which is pretty awesome. So like a new miner to join the network from scratch doesn't need to download the full history. They just download like the current working set of the nullifiers, which I guess might be kind of similar to the current working set for a Bitcoin node of open UTXOs.
Okay, very cool. Because I think like the thing though there is like kind of wrapping like these two things together is like you can have one side of it that scales transaction throughput, and then you can have another kind of system like what you mentioned with zones that are able to like connect to Zcash and provide kind of more functionality via these like roll up execution environments. It does kind of seem like, and this is the same thing in Bitcoin, whereas like they're working on some people like, another roll up team is like very exclusively focusing on this, where they're building an execution environment similar to Citrea, but they're also building another execution environment that works kind of more for specifically for better privacy and better transaction throughput. So you can, and the cool thing is you can actually have these two systems if they're using like different service providers to post this data to the data availability layer. You can actually share the service provider. So like a roll up in Zcash could also use kind of I believe there's like a third party responsible for like aggregating these nullifiers and posting it to Zcash. Like they could use the same person, and then that can kind of allow them to share and minimize the amount of people that you need running these types of services, which can be good or bad, but like there's some like really cool nuance there. But yeah, guys, I think we're at the hour. This was like a really fun conversation. I got to learn more about Tachyon, which I've been like reading about, but not fully understanding. Yeah, I got to learn more. And then I also got to like talk about rollups on Bitcoin, which are like one of my favorite things. So yeah, I don't know if you guys have any closing thoughts, but I feel like this is a good place to maybe park for now, because I feel like we're doing another space where we need to talk about rollups on Zcash, and we can probably schedule that in the future. But yeah, just wondering if you guys have any closing thoughts.
Yeah. So yeah, it was good to talk about all these. I think we gave kind of a layout for what's kind of going on with all the roll up that people call it, and also what's all the fuss about kind of the bridges and what changes a little bit. And I think combining this with the Tachyon part is also interesting, because from what I understand, you can now have a single Halo proof, let's say, from Zcash, and to build trust minimized bridges from Zcash to alternative environments. And I think this can be actually an interesting starting point for a Zcash rollup that has a bridge as well, rather than being a sovereign rollup as well. But yeah, it was really cool to learn about all these, and also really cool questions as well. So thanks, Janusz, and also thanks, Nate, for all the answers.
Yeah, thanks. I loved learning more about rollups, and I'm especially excited for Bitcoin extensions or improvements. So uh, yeah, so I'm excited to see those pan out, and I would love it if Zcash could bridge to any of those. So just some more of my interests. So I'm glad to be here and learn.
Yeah, Zcash Citrea bridge coming in 2026. Let's see.
Cool. Well, yeah, guys, we can wrap it up there, and yeah, I think ZK team, Shield Labs team, we're definitely due spaces on Zcash and rollups. Nate, you've motivated me to write another forum post, so I will be in the forums in like the next couple of weeks. But yeah, I think this is a good place to wrap up. And guys, thank you so much for the time, and yeah, excited to carry the conversation forward.
Yeah, likewise. See you guys.
Yeah, take care.